When you give developers a powerful local-first data layer and the latest AI tools, what do they build? Let's find out. In our recent AI hackathon, we saw some incredible submissions. While our top 3 winners took the main stage, we also had some specific bonus categories that produced absolute gems. Today we are breaking down 5 bonus category winners of the PowerSync AI Hackathon. We will explore what each of these specialized projects does, the unique technical choices they made, and how they push the boundaries of what's possible with AI and offline-first architectures. This is a debugging memory system for teams. It captures bugs, analyzes them with AI, stores the results locally, and makes past fixes searchable so teams can stop solving the same problem twice. What gives it real weight is how local first the whole experience is. Reads come from local SQLite, writes queue offline, and the app keeps working even when the network drops. The more interesting technical choice is how they handle semantic search. Instead of relying on a cloud vector database, DevTrace runs transformers.js directly in the browser to generate embeddings locally. These embeddings are stored right in your local SQLite database using PowerSync. That means you get instant AI-powered semantic search for similar past bugs with 0 network latency, even when you're completely offline. Combine that with their 8-tab breakdown of each bug and AI-assisted follow-ups, and you have a seriously powerful offline workflow. It also handles live collaboration at both session and project level, which makes the whole product feel like a shared debugging workspace instead of a personal notes app. This is a great example of how local-first architecture can make an AI app feel fast, resilient, and genuinely useful in day-to-day work. This is an incident reporting and response platform for teams working in rough environments. Field workers can report incidents offline, supervisors can review them in real time, and the data syncs back when connectivity returns. The part that immediately separates this from a typical mobile submission is the Rust layer. The project goes beyond a normal mobile app and builds a real Rust PowerSync Edge app for rugged field hardware, which already makes it stand out. It's a full system: mobile reporting, a supervisor dashboard, AI triage, and an edge monitor for critical incidents. And the AI pipeline is designed to degrade gracefully. If the full AI path is unavailable, the system can still fall back to heuristics instead of blocking incident handling. On top of that, the edge devices only subscribe to site-specific critical incident feeds, which is a really smart sync design for constrained environments. This is the kind of project that shows how offline-capable sync can support serious field operations when the network is unreliable. This is a local-first memory system for codebases. It captures lessons from docs and commits, and the important detail is how much structure they preserve. It stores documents, chunks, structured lessons, embeddings, and anti-pattern metadata, so the knowledge stays reusable instead of turning into another pile of notes. Another good decision here is that they don't trap the knowledge in the UI. It exposes the memory through MCP tools, so the same knowledge can be used from the browser, your IDE, or an AI agent. Supabase plays a meaningful role here as the backend for storage, vector search, and AI-driven ingestion. And the ingestion pipeline feels surprisingly product grade for a hackathon project, with asynchronous processing, retries, progress tracking, and cleanup instead of a fragile upload demo. That makes the whole app feel like durable project memory instead of a one-off assistant. This is a strong example of turning scattered project history into something the whole team can reuse. This is an offline-first app for tracking generator maintenance. It's built for situations where power is unstable, connectivity is unreliable, and knowing when equipment needs servicing really matters. The key idea here is the Mastra-powered maintenance workflow. The app searches real sources, generates structured maintenance plans, and turns that into something the user can actually act on. It also has explicit repair logic for bad LLM output. So if the generated schedule comes back malformed, the app can fix or downgrade it instead of just breaking. That makes the whole workflow feel operational rather than experimental. This is one of the clearest examples of AI doing useful work in a constrained offline-first environment. This is an on-device AI assistant for wildlife park rangers. It's designed to work in the field with no connectivity, helping rangers query patrol data, log incidents, and get briefings without relying on the cloud. The defining choice in this project is that AI runs locally. This is truly on-device AI, not just an app with an offline fallback, which is exactly what you want for a ranger workflow in the field. And the voice incident logging is a genuinely good field workflow. Rangers can speak reports naturally, capture incidents on the spot, and let PowerSync sync everything back once the device reconnects. This is a great reminder that the best AI products are the ones that still work when the network doesn't. A massive congratulations to all the developers who took home a bonus prize in the PowerSync AI Hackathon. These 5 projects prove that when you combine AI with a robust local-first data layer, you can solve real-world problems in ways that are not possible with a standard cloud-only approach. Whether you're building field tools, team workspaces, or standalone edge agents, PowerSync gives you the real-time sync and offline capabilities that you need to make it work flawlessly. If you're feeling inspired to build your own resilient AI application, head over to powersync.com and start today.